our recording for those who are in attendance today. And we're set. So, again, today is AP Statistics 2020 Exam Review Part 7 if you're watching live or if you're watching the recording on YouTube or any other method. Thanks for joining us today. And we're going to go through and we're going to be talking about Unit 3, which is sampling and experiments today. So there's a couple things. I do want to bring your attention to the collegeboard.org website. So I'm going to go to it, cb.org/AP2020. I want to bring your attention to this because some other subjects have already started their exams, and you may want to be careful with this. To be prepared for exam day, a couple things that you want to do is you would like to also make sure that the exam demo that I have made, that you're able to follow through that as well. And taking one of the practice exams is probably also going to be in your best interest. But there's a couple things that I know people were having issues with. One of the things people were having issues with was getting their e-ticket to load on the exam day right when it was time, because there were so many people logging into the exam. So if you 2 days before the exam, you'll get your e-ticket. It'll either be on AP Classroom or in your email. It really should be in both. But you'll want to, if you'll write down the important information from your e-ticket, then just in case that doesn't load on exam day, or print it out so that way you have it and you don't run into any technical difficulties. And then you also want to make sure that your computer and your browser is up to date. Okay, so trying the exam demo will make sure that your browser's up to date. And then there is an exam day checklist that you can kind of look through where it says to write down your 8-character AP ID, write the name of your exam, the exam date, the start time, your check-in times 30 minutes before, making sure your device is plugged in. When you click on a link, the browser opens in Chrome. The exam will not open in other browsers, so Chrome, Firefox, Safari, or Edge. That you practice with the exam demo, so that confirms that the device and browser will be able to access the exam. If you're typing your exam, you want to make sure you've opened a Google Doc or a Word doc and you've typed your AP ID and initials at the top. If you're handwriting your exam, that you've prepared a set of pages, a set of 2 pages, 2 sets of pages, one for question number 1 and one for question number 2, and you've written your AP ID, initials, and the page number at the top. That you've looked at the list of required materials that we talked about, which was the formula sheet and the how to type the symbols in on a computer. That you've reviewed the exam security guidelines and understand that any cheating or anything will go directly to the colleges. So you need to make sure you do that. If you're at home, you've asked others to avoid disturbing you, and you've let them know at what time you're going to do this. Also make sure, because sometimes the internet can be overloaded. So if you're able to, if you're at home and you're on a wireless network, if you'll make sure that others in your house aren't using any wireless during that time. I know that can be hard sometimes, but if they're able to, on May 22nd from 1:30 until 3, if they will not be using any wireless connections, that will be a good idea. Mary asked if I recommend writing rather than typing. What I would recommend you do is to, I don't recommend, I mean, here would be the issue. So if you write your exam, then what you'll have to do is you'll have to take a picture of it on your phone, and then you will have to upload that picture to Google Drive or to your computer, however you want to do it. You could email that picture, whatever, but upload that picture from your phone to your computer. So if you put it in Google Drive or something like that, and then you would have to take that picture file and put it onto the exam. The other option, I think the easiest option, I'm not going to say that writing the exam is not an option. It definitely is. But I think just by looking at what's given, the easiest option is going to be splitting your screen and having half of your screen as a Google Doc and the other half, or Word or whatever, and the other half of your screen as the question on the computer, and then just typing your response in the Google Doc and then hitting copy and paste. Because I think what that allows you to do is that allows you to work until, almost the last minute, and then copy and give yourself time to just hit copy and go over and paste it and make sure it submits. Whereas if you are writing it, you're going to have to take a picture with your phone. You're going to have to make sure your phone uploads it to the computer, and then your computer puts it to the file, where that could lose you some minutes that you might have to work on it. But what I would do is, whichever one you think you want to try, I would try that when we schedule this practice exam. So I would try to do it on this with this 45-minute practice exam. If it works for you that way, then go with it. And if you feel like that's not going to work, then you can try to look at some other options. Now, you want to make sure that you have, so those are all the things. Once the exam started, you want to make sure you don't refresh the browser. I would also recommend not having any other tabs up other than the Google Doc and the actual exam. So you don't want to have a bunch of other tabs or anything that could cause it to stop. You'll keep the exam question open on your device so that you can see the timer and you can see the 5-minute warning. When you see the on-screen warning that says there's 5 minutes left, it says you can stop working on your response. You don't have to stop when it says 5 minutes, right? But you have to understand that to copy and paste and then submit it, you've got to have enough time before it hits 0. You also understand if you don't attach or paste your response and hit submit before it hits 0, you will not get any points for that question, which will then kind of you'll either have to take a 0 for that, which would mean you're going to do very, very poorly, or you would have to retake the exam in June, a couple weeks later. If you accidentally close your browser or tab, so if you accidentally hit the X button or temporarily lose internet connection or experience some other disruption, you can actually still go back in with your exam e-ticket and it will pick up where you left off. Obviously, you'll lose the time that you missed, but you can rejoin the exam if something like that did happen. If you can't rejoin the exam or something happens that you're not able to submit, then you can create a makeup test and there is a form to complete for that. But hopefully it'll all work perfectly on exam day if we've gone through these things beforehand. All right, so those are the kind of just some tips that I was seeing, and I've seen some from, I think there's a couple subjects that have already taken their exam, and our exam is the very last one. So it is on May 22nd. They started May 11th, and with our exam being the very last, then we're going to be able to see what problems people had that occurred with the online exam, and hopefully those problems will be fixed and updated, and then we'll be, by the time we take ours, we should be in good shape as far as that goes. Okay, so with that, let's take ourselves, we want to go to the Stats Medic review course, and in that review course, we are going to Unit 3 multiple choice. We want to go to Unit 3, and we want to go to multiple choice. And in the Unit 3 multiple choice, there are 10 questions, and those 10 questions are going to talk about sampling and experiments. So that's what we're looking at today, the sampling and experiments. So one way to follow along is to go into the Stats Medic course like I am now and go to Unit 3 Practice Multiple Choice. Another way to follow along is to download the PDF and have it printed out where you can write your things. And some of you in the face-to-face class have that already. So I'm going to be going through my printout, and you can also go through either your printout or follow on the AP Stats course. Okay, so is everybody ready to begin on the multiple choice? You got the paper or found the screen that you need to be at? All right. Alexis, Emma, Jacob, yeah, Mary. Okay. All right, so let's go through question number 1, and then I'll have you guys kind of, go through and give me some answers or what you think is the correct answer. So number 1 says, an AP statistics class starts a project to estimate the average number of hours a student at their high school sleeps per night. Their high school has 1,200 students, and they take a sample of the first 120 students that arrive at school on a particular day. They ask each of the 120 students how many hours of sleep they got the night before, and then they calculate an average. Which of the following statements is an accurate description of the elements of the survey? So what is our population? Our population would not be the 120 students surveyed. Our population would be the 1,200 students in the high school. So we know that that's not true. Okay, so we can look at part B. Part B says the sample is the 1,200 students of the school. Well, that wouldn't be true. That would be our population, would be the 1,200 students of the school. C, the sample is the 120 students surveyed. The population is the 1,200 students at the high school, and the parameter of interest is the average number of hours a student at this high school sleeps per night. That looks great. Okay, so our population is everything we want to know about. We want to know about the whole high school. The sample is what we actually are able to gather information from. And then the parameter of interest is just what we're interested in learning about in this problem. And we're interested in learning about the average number of hours a student sleeps per night at this high school. Okay. So D, the problem with D is that it's saying the average number of hours a student at this high school sleeps per night is the statistic. That is just that's the parameter of interest. The number, what that number would be our statistic. And E says this is not a survey because a convenient sample was used. I do think a convenient sample was used because they just asked the first 120 that came in, so that made it really easy. But that's a problem with the survey, but that doesn't make it not a survey. It makes it not a really good survey, but it still is a survey, even though it uses a convenient sample. Okay, so let's move to number 2. At a high school, the cafeteria staff provides optional comment cards to students eating in the cafeteria. Students who wish to make a comment can obtain and fill out a comment card and return it to a drop box in the front office. At the end of the semester, the staff analyzes the responses and finds that 72% of the students who filled out a comment card recommend major changes to the food selection. What conclusion can the cafeteria staff draw from these responses? Can we look through this and see if anybody has an answer there? So there were comment cards there. If they wanted to make a comment, they could return it to the front office. And then at the end of the semester, they found 72% recommended major changes. Yeah, Gavin says D, and it actually is D. So let's look at why it is D. D says the responses were from a voluntary response sample. Now, that is true. So they voluntarily responded. People didn't have to. They picked up the comment card if they wanted to, and then dropped it at the front office if they wanted to, right? They didn't have to. And at the end of the semester, there were 72% of the students who filled out a comment card recommended major changes. Well, the reason the cafeteria staff shouldn't use the results to draw any conclusions is because what we're seeing from a voluntary response is strong opinions. And especially in this case, if they're asking you about the cafeteria food, then most likely, if you're filling out a comment card, you're either really, really happy or you're dissatisfied with it. And so all the people that are just okay and say things are fine, they're not going to fill out a card. And that may be a majority of the students. But the students that really feel like it's not good or something's not going correct, they're going to fill out that card and try to get their voices heard. So even though 72% of them may have said that they want major changes, that may just be a small portion of our student population. And we're not hearing from everybody. We're not hearing from a simple random sample. We're only hearing from the extremes here in question number 2. Okay. All right. So let's go to question number 3. Question number 3 says, the career placement department at a university wants to administer a survey to determine student awareness of the resources offered. The department expects that student awareness of the career placement resources will vary significantly depending on how many years a student has attended the university. So they plan to randomly select 30 freshmen, 30 sophomores, 30 juniors, and 30 seniors. This type of sample can best be described as. So what type of sample is it when they want to randomly select 30 freshmen, 30 sophomores, 30 juniors, and 30 seniors? When they want to split those up into groups. Gavin says stratified. Anybody else? Do you agree? We want to split these up into groups. So what type of sample would it be? Do we agree with that? Jacob, yep. Okay, yeah, that is correct. So this is a stratified sample. Now, let's look at the part that makes it stratified. The strata are the groups, which are freshmen, sophomore, juniors, seniors. So we think that their grade is probably going to have a big impact on whether they know where the career placement resources are. More specifically, probably the longer they've been at the school, the more aware they are of those resources. So let's look at the 5 just so you know, because we need to know all of these. A simple random sample would just mean everybody was put together. So if there was 120 of them, we would just sample 120. They would all be put together and given an equal chance of being selected. A systematic sample means you have a system in place, which means like you pick the every 5th person that walks through the door or every 10th person in line. That would be systematic. Stratified, we just talked about. A cluster sample is when you split people up into groups based on where they already are, and then you randomly select some of those entire groups. And then a block sample only occurs in an experiment, remember. So blocking is only in an experiment, and it would only be after you have collected your sample. All right, number 4. Major League Baseball has recently been evaluating the timing of various events during games in an effort to improve the pace of the game. MLB wants to know how long a mound visit, defined as when a coach pauses the game to visit the pitcher on the mound, takes on average. MLB randomly selects 100 games over the course of the season and records the length and seconds of every mound visit that occurs in that game. The sample of mound visits can best be described as what? So they randomly select 100 games over the course of the season, and they record the length and seconds of every mound visit that occurs in that game. So what type of sample would that be? Okay. Um, it's it's not going to be a simple random sample. So yeah, Jacob, here's the problem with that. So they randomly select 100 games over the course of the season. That if that was all they did, that would be a simple random sample. But once they select those 100 games, they record the length in seconds of every mound visit that occurs in that game. That's your cluster. Okay. So basically, there's probably so each team plays 162 games in a regular season. So like over all the games, there's thousands of games that go on in a season. They're selecting 100 of those thousands of games, but then they're giving us every single mound visit from those 100 games. So they're selecting a they're selecting a sample, and then they're giving us everything in that game. So that's a cluster. So that would be a cluster sample. It's when you randomly select something, but then you give us everything in that group. So a game would be a group, and then you give us every single mound visit in that game. So that's what makes it a cluster sample. That was a difficult one, and simple random sample was the most common answer. So don't feel like, just because you picked that, you were off. That is usually the case. So hopefully you got to read it really carefully, and the vocabulary is also very important in this unit. Number 5, 20 volunteers with high cholesterol were selected for a trial to determine whether a new diet reduces cholesterol. The volunteers were given a low-carb, low-calorie diet. After 8 weeks of the diet, the average cholesterol of the volunteers dropped a significant amount. This study is an example of what? What type of study is this? Give it a chance. Everybody give their guess here for this one. What do you got? Okay, so which ones can you eliminate? Okay, so here's what we're gonna say. It's not block design, so they have not like a block design means they put them into different groups based on that. Right? Gavin says it's between controlled and uncontrolled. That's true. Okay, it's not an observational study. An observational study would be when we watch people do what they're already doing. So we wouldn't need volunteers and we wouldn't have to tell them to try this new diet. Not a block design because we're not putting them into different groups based on some characteristic. Double blind means that the people in the study wouldn't know what they were eating or whatever, and the people giving them the food wouldn't know. That's not true in this case. So really the key is controlled and uncontrolled. So let's talk about that. So let me explain what it means, and then maybe you'll change your answer or maybe you'll keep the same. So a controlled experiment means you have a treatment group and you have a control group. So for instance, if you're trying out a new drug, you have a group of people that are taking the new drug, and you have a group of people that are taking a placebo. If you're trying out a new diet, you would have a group of people that are trying the new diet and a group of people that may be trying a standard diet, right? And the reason for a control group would be because so we can have something to base our answer off of. So just because these people just because their cholesterol dropped, how do we know that it drops because of the diet? Well, we don't. But if we had a control group, that had a regular diet, and then we had this group that had a new diet, then at the end, we could see, is there a significant difference between people on just this regular diet and people on the new diet? And that way, we're able to say that the new diet actually caused the difference. So this is an uncontrolled experiment, and the reason is because we don't have a group to compare it to, okay? So everybody's getting the new diet, and we see that their average cholesterol went down. But we don't know if the new diet actually caused that or not, because we didn't randomly assign them. We didn't give them one a new and one the old. We didn't have anything to base it off of, right? So we are just, so that's why that would be an uncontrolled experiment. So control is not like, some people think control means like I've got control over these people. Control means you have a control group, and a control group means you have a group that goes with your treatment group, and it allows you to make comparisons on those two. Because maybe the control group, maybe the people with a standard diet, actually their cholesterol dropped significantly too, and there wasn't a difference between the two diets, right? So then this new diet wouldn't be very effective. So that's why a control group would be necessary and would be good to have in this problem. All right, so we're learning stuff today, which is great as we get some new stuff. These are tough questions, and vocabulary is always some of the hardest. So let's go to number 6. The Department of Natural Resources is planning a study to determine whether breakwaters help decrease erosion at a large lake. They divide the shoreline into 100-foot plots, installing some with breakwaters and some without. However, the east and west shorelines of the lake receive very different wave patterns due to the wind. The DNR, which is the Department of Natural Resources, suspects this will affect the responses to the breakwaters. Because of this, the Department of Natural Resources plans to treat each shoreline as a different group. So this is an example of what, okay? So because they know that the shorelines are going to be different, then they're going to group them. So what type of experiment are we talking about here? Yes, absolutely. So this is a blocked experiment. So blocked means when you're doing an experiment, and so obviously this is an experiment because they're dividing the shoreline and everything, and you know that there's something that may affect your results, so you're going to put them in different groups. Now, Mary, the reason it's not matched pairs is because matched pairs means you're doing 2 treatments to one thing. So in this case, we're not doing 2 treatments to one thing. We're just putting all the plots that are on the east coast are going to be one group, and we're going to make a conclusion about them. And all the plots that are on the west coast are going to be another group, and we're going to make a conclusion about them. So in our final conclusion on our experiment, we may have 2 different conclusions. We may have the east may be completely different than the west based on their wave patterns due to the wind. So kind of like if you know males and females are going to feel differently about something, you may want to split them up and have males as one group and females as another group. And your conclusion for males may be completely different than your conclusion that you got from females. So in this case, we know that the east and the west have completely different weather patterns. So we're going to split them into different groups to see if the East Coast answer or response is different from the West Coast response. And that gives us the block design. All right, so number 7, 40 adult males volunteered to participate in an experiment. Half of them are randomly assigned to take a caffeine supplement before working out. The other half are assigned to take a placebo before completing the same workout. Remember, the placebo it looks just like the caffeine supplement, except it's just a fake drug, right? During the workout, heart rate monitors will be used to measure each participant's heart rate. The study found that those who took a caffeine supplement had significantly higher average pulse rates during the workout. What conclusion can be drawn from the study? So we're seeing that we're giving half of them this caffeine supplement. We're giving the other half the placebo. And at the end, we're able to see that those who took the caffeine supplement that they had a significantly higher average pulse rate during their workout than those that took the placebo. So what are we able to tell from that? Yep, Alexis, I absolutely agree with you there. So caffeine supplements will, on average, not always, right? They will, on average, raise the heart rates of adult males similar to those in this study during a workout similar to the one performed in the experiment. So we have learned, you have to be very specific with your conclusion, right? So we've learned that caffeine supplements will, on average, raise the heart rate of what? Well, in this case, it was 40 adult males. So of adult males, but what type of males? The ones that volunteered, right? So similar to those in this study during a workout, similar to the one that they did. Okay. So we can't say like for all workouts, the caffeine supplement's going to raise their heart rate. We can't say for all males or for all people. We can only say that for people similar to this, that we expect the caffeine supplement is going to do this. And again, it's on average or some of the time. It doesn't mean that it's going to do it all the time. It just means on average that that's going to happen. It's going to raise your heart rate. Okay. 20 is a small group, but it's not too small. So there's never a group. If you get significant results, it doesn't have to be, they don't have to be a certain number to be significant in an experiment. Those that took the caffeine supplement had a higher average heart rate, but it would not be correct to conclude caffeine caused this to occur. In an experiment, you can actually say that one thing causes the other to happen. So that's why B is not true. C, the caffeine supplements cause the heart rates to increase due to the placebo effect. Well, the placebo effect means when you take a fake drug, you actually still feel the same experience. So people thought they were taking a caffeine supplement would actually increase their heart rate. So that would actually not, that would mean that the placebo should have had a high heart rate too. And so that would not, C is not saying that. So the placebo effect would actually mean that those taking the placebo would have had a high heart rate. And then D, caffeine supplements will on average raise the heart rates of all adult males during a workout. That's the issue here. It says all adult males. A lot of people would pick D, but notice these are 40 adult males who volunteered to participate in the experiment. So we have to know that we're only talking about adult males similar to those in this study, because it may be adult males that already work out. It may be adult males that are healthy. It may be adult males that are young. It's just similar to our volunteers. Okay, so let's move on to these last three. So we're going to get to question number 8. The following 8 truck models will be used in an experiment with 2 treatments. The trucks are listed according to their make and size. If an experiment uses a block design based on the size of the truck, so they're blocking into groups based on the size of the truck, which of the following is not a possible list of trucks that received the first treatment? Anybody got an answer there?
C.
I got all over the board on this one. All right, so what should happen? Let me go through and explain it to you. So what should happen is if we're blocking by size, we should get 2 mid-size and 2 full size in each group. Okay, so basically, if we're blocking based on size, then we should have in treatment number one, we should have 2 mid-size and 2 full-size. And in treatment number 2, we should have 2 mid-size and 2 full-size. Okay, so let's look at A. Colorado, Sierra, Frontier, Tundra. Colorado and Frontier are mid-size. Sierra and Tundra are full-size. That's 2 and 2. That's good. B. Colorado, Canyon, Titan, Tacoma. Well, in this one, there's 3 mid-size and 1 full-size. So B can't be an answer. So that is going to be our answer here. C. Colorado, Silverado, Canyon, Sierra. You've got 2 and 2. So that is true. So C can happen. Canyon, Frontier, Titan, Tundra. That's 2 and 2. Silverado, Frontier, Titan, Tacoma. That's 2 and 2. So all A, C, D, and E are possible. No, it's okay. These are tricky. They really are. A, C, D, and E are all possible because they have 2 mid-size and 2 full-size. So you have an equal amount of each one, right? Because if you're blocking based on that, you think that might be an issue. So you want to make sure you've got an equal amount of both. This is the only one. So in B, you would have had Colorado, Canyon, and Tacoma. So you would have 3 mid-size and 1 full-size. And if you think that's an issue, then you're going to have more mid-size in this treatment group, which then means you would have more full-size in the other treatment group. And it really might be the size of the truck that makes the difference and not the actual treatments. Yeah, it's the one that is not possible. Which of the following is not a possible list of trucks that could get the first treatment? So A, C, D, and E are all possible because they're 2 and 2. But B is 3 and 1, so that makes it not possible. All right, let's move to number 9. Diverticulitis is a common intestinal ailment. To test a new medication, a hospital takes 50 volunteers who have a moderate case of the disease. The volunteers are randomly assigned to 2 treatment groups, one receiving the old medication and one receiving the new medication. The pills are distributed in unmarked pill forms so that the patients and the medical professionals do not know which medication the patient is taking. Which of the following is true? Now, I want to go to number 3. This is an example of a double-blind experiment. That is absolutely true in this one because, and that's a quick one to see, because it says the pills are distributed in unmarked pill form, so patients and professionals do not know which medication the patient is taking. So the people giving the medication don't know which medication it is, and the people taking the medication don't know which one it is. Now, number 1, if the results show the new medication is significantly more effective than the old, we can conclude that the new medication will be more effective for all people that have a moderate case of the disease. Now, the reason we can't conclude it will be effective for all people that have a moderate case is why? Why can we not conclude that it would be more effective for all people that have a moderate case of the disease? Yes, it has to be similar to these 50 volunteers, right? And it's only at one hospital, absolutely. So it's only at one hospital and it's 50 volunteers. So the 50 volunteers is the key part. So we would have to say it'll be more effective for all people similar to the volunteers that have a moderate case of the disease. Number 2, the group receiving the old medication serves as a control group. Is that true? So you have the treatment group is getting this new medication. Do we have a control group that is getting the old medication? We absolutely do. So 2 is correct. And so that makes the answer D, which is answer choice 2 and 3. So we have a control group, a group to compare our new medication to. That's the group getting the old medication. And it is a double-blind experiment, meaning the people giving out the medication and the people receiving the medication are unaware of which treatment it is. All right, we're going to keep going. Going to move forward to question number 10, our last multiple choice question of the day. A study is conducted to determine if the blue light from a tablet device will affect the fall asleep time of people in various age groups differently. Volunteers for the study are grouped by age, 18 to 30, 31 to 50, and 50 plus. Half of each group is assigned a standard tablet. The other half is assigned a tablet with a reduced blue light. People in each group are asked to use the tablet for 10 minutes before bed, and their fall asleep time is recorded. Which of the following is correct? And I'm going to go ahead and give you this, and then if you have a question, you can ask about it. The answer choice is D. So the blocks, how we're separating them, that would be your groups. Your blocks are your 3 age groups. So we're separating them by 18 to 30, 31 to 50, and 50 plus. Your treatments are then either the standard tablet or the reduced blue light tablet. So they're either going to get the standard tablet or the reduced blue light. And then your response variable, what you're looking at to their response is how long it takes them to fall asleep. So the blocks are the groups that we're splitting them up in. That is the 3 age groups. The treatments are the standard tablet or the reduced blue light tablet. And your response is how long it takes you to fall asleep. And that is question number 10. And that wraps up the multiple choice for today. So if you notice, there was no math on these, right? There's no math involved. It's all vocabulary and writing when we're talking about experiments. So you can expect to see just a little bit in your on your exam about an experiment. It could be as simple as, what type of experiment, is this an experiment or an observational study? It could be as advanced as, what happened in this experiment? What type of experiment is this? There can be many options there. And then, that might be one part, and then the next part might give you a p-value, and you might have to explain the p-value. And then the next part will come from another unit. It might give you linear regression. You have to explain that. So you're just going to see probably, again, like one part of a question from each unit is what you're looking for here. All right, so let's go to the Unit 3 free response question. If you follow in Stats Medic, that's kind of your last, part in Unit 3. I'm going to read this real quick. We'll go through A, B, and C, and we'll be done for today and finish up Unit 3. Yes, so Mary asked, sorry, I just looked in the chat. Can I review the difference between strata and blocks? So stratified is what happens in sampling. So stratified is splitting them up into groups, but it is not an experiment. So stratifying is when you split people up into groups before you take a sample. So like if I have 800 students at the high school, I go ahead and split them up into freshman, sophomore, junior, senior, and then I take a sample from each group. What blocking is blocking is used in an experiment. So blocking is when I already have my volunteers and then I block them based on some condition. So for instance, in this case, I was blocking them after I got all my volunteers. I knew that their age group would make a difference in the results. So I went ahead and blocked them based on age group. So I split them up based on age group. So blocking happens after you've already got your sample, and it happens in an experiment. The stratified is a sampling method that's used in an observational study or when you're conducting a survey. All right. So Unit 3, practice for response. The two tires on a bicycle experience wear much in the same way car tires do. Repeated contact with the road or sidewalk will wear down the raised rubber, giving the tire less traction. A major tire manufacturer has developed a new bicycle tire design they hope will reduce wear. After running several rounds of testing in laboratory conditions, they want to test the tires in real-life biking conditions. They find 20 volunteers who bike on a daily basis. The volunteers are each given a new bike of the same model for the duration of the experiment. The volunteers are to bike as they normally would for a month, then return the bike to have the wear of the tires measured, determined by millimeters of tire depth remaining. The manufacturer knows these results must be compared to their standard model tire, so they will use the standard model in the experiment as a control group. A, the manufacturer determines a matched pair design would be most appropriate to compare the wear of the new tire to the standard tire. Describe how to implement a matched pair design. Okay, so basically what you would do in a matched pair design is, the best way of doing that is you want two treatments for the same person, right? So it would be best to put one new tire and one standard tire on each bike. So that way you know it's getting the same amount of use, right? So if you have a new tire and a standard tire on each bike, then you know it's getting the same amount of use. And then you would want to randomly decide, so randomly select which one goes on front, which one goes on the front or back. Now, how could we randomly select whether the new tire goes on the front or on the back? What's something we could do that would have a 50-50 chance? Yep, flip a coin. Absolutely. So you think of something that has a 50-50 chance. You could also say roll a die, and if it's even, then it goes on the front. If it's odd, it goes on the back. Whatever you want to say. But flipping a coin is the easiest one. So we randomly select which one goes on the front or the back. The way you can do that is by flipping a coin. Okay. If you flip a coin, if it's heads, we'll say the new. Heads means the new goes on front. Sorry. And tails means the new goes on the back. So you're just setting up how you would do a match pairs experiment. Okay. Then at the end, the wear of the tire. So at the end, the wear of the two tires on each bike will be compared, right? So we're going to just look at each bike specifically, and we're going to say, what's the difference between the new tire and the old tire? And the reason you would want to do match pairs here is because if you didn't, you might find somebody that rides their bike all the time, a ton, and even though they have the new tires, it's wore down a whole lot more than somebody that doesn't ride their bike that much that has a standard tire. But since we're putting the new tire and the standard tire on the same bike, then we have taken out a confounding variable. And the confounding variable here would be how much you actually use your bike. So we've actually got rid of that confounding variable because now we know it's going to get used the same because it's on the same bike. And that's basically what I just explained. So the goal is to make the conditions for the two tires as similar as possible. That's our goal. So, for instance, so using one bike helps us ensure both tires get the same amount of use and weather conditions. So they're both exposed to the same conditions because they're on the same bike, right? So, and that's the goal. We want to make them as similar as possible. We want to make it to where the only difference is the tire, nothing else, okay? Okay, so C says, at the conclusion of the experiment, the manufacturer finds that the new tire design has experienced statistically significantly less wear than the standard tire design. Can the manufacturer infer or make a conclusion that the new tire will cause significantly less tire wear for all bikers? So the answer would be no, because we used volunteers. We can only generalize our results to people that are similar to the volunteers. And that's really the case in most experiments. Okay. So we used volunteers in this experiment, so we can't just generalize our results to the entire population. We can only generalize our results to people similar to the volunteers. And that's the key here. Because we don't know if the volunteers are representative of all bikers. Maybe the volunteers are people that bike all the time. Maybe the volunteers are just recreational bikers that only bike every once in a while. So we only know that if we do see a difference, we only know that we can generalize those results, so we can say that it is statistically significant among people similar to the volunteers. Does anybody have a question here on this practice free response unit 3? I would look at the 2 free response questions you did for unit 3, and I would say something from those. Those are the main things from this unit. There will be a part of a question, like for instance, this could easily be added to the end of any question, right? And if you look at it and you see that there's volunteers, then your answer, they're wanting you to know we can't generalize our results to the whole population. It's only for people similar to the volunteers. Type of experiment to use, they could ask you how to design an experiment, which is kind of what we're doing here. So all those things can be easily just put into a problem. So they're things that are likely to be seen on the exam as one part. And remember, when you only have 10 parts, because you've got 2 questions with 5 parts each, then this is going to be very important. So I'm going to go back and share my screen real quick to the Stats Medic course. If you look, we have finished Unit 3 sampling and experiments. We're really getting a good way through. Today was day 7, so we're 7 out of 13 days through on our review sessions. So Unit 3 sampling and experiments is done. So far, we have completed the introduction. We have taken the diagnostic test. We have studied Unit 1 variable data, and done free response and multiple choice questions there. We've gone through Unit 2 variable data, and done free response and multiple choice questions there. We've gone through Unit 3, which is sampling and experiments, and done free response and multiple choice questions there. So tomorrow will be day 8 of our review. We will move to probability. Now, probability is a big unit. So there are 5 sections that we have to look at tomorrow, okay? General probability, binomial. What about when we combine random variables, the normal distribution, and geometric? So there's a lot of stuff. If you go back and remember probability in the AP Stats course, it was the longest. And so probability is something that sometimes separates people from a high exam score and a low exam score. So it is a very important section in statistics. So we're going to spend Thursday on probability and Friday as well. So days 8 and 9 of our review is going to be on this Unit 4 probability. And then days 10 and 11 of our review will be on sampling distributions. And then we will also spend 1 day on confidence intervals and 1 day on significance tests. I've sent out a survey. If you will please respond to that survey and let me know what times you are available to take a practice AP statistics exam. I have set up a practice exam for you to do, and you will go online and it will definitely help you as far as getting ready for the actual exam. So if you'll respond to that survey, if you haven't already, I'm going to take those responses hopefully tomorrow, and I'm going to set us up a time for next week in order to do the AP statistics practice exam. So it is 11. I've used my hour. So thank you guys for being here. I really appreciate all your time and effort in this. And if you can continue to join, we'd love to see you every day. If you have any questions, I can take those now. If not,